Let's go. All right. So when you got to solve an equation with variables on both sides, your goal is to have one side have the variable terms and one side have the constant terms. By the way, if we say something is constant, what does it never do?
Never change.
Never changes. Looking at this example 1 problem, which terms would you say are constant? 5, negative 11. They're the constants because they'll never change. They'll always be 5 and negative 11. 6x, its value changes depending on what x is. Negative 2x changes depending on what x is. So remember, when you're solving an equation, your goal is to get one side to have constants and one side to have variables. And when you do an equation with variables on both sides, remember last week we talked about was we were trying to take off? We always took off the side that had the least. We still want to do the same thing. We want to take off from the side with the least. And I always want you to start these by dealing with the variables. So ladies and gentlemen, which side of my equation, left or right, has the smallest amount of x's? The right does. Negative 2 is smaller than 6. You're looking at the coefficients. Ladies and gentlemen, how do we get rid of negative 2x? Correct. So since this is a minus 2x on the right, we'll do the opposite to get rid of it. We'll add 2x. Do the same onto both sides. So 6x and 2x gives us still minus 11 equaling 5. We have to add the 11 because remember, our goal is to get the variable by itself. So there's 8x still, and x equals 2. In fact, you are correct. Okay. If you haven't already, you can go and close your Chromebooks right now because you don't need them. Okay. Well, like we also saw yesterday, sometimes we have to simplify before we can solve. So take a look at example 2. 10 times the quantity negative 4 plus y equals 2y. What do we do first? Manford? Correct. We'll get rid of the parentheses by distributing. That means we multiply everything inside the parentheses, every term, by 10. What do we get? Anyone? Now, I'm going to violate what I just said because I said normally we take off from the side with the least. Well, guys, which side has the least y's here?
2y.
2y is the smallest. But notice that on that right side, it's only variables. And the goal in solving an equation is to get one side to have only variables and one side to have only numbers. So even though the right side is smaller, I'm still going to take everything to the right because the right side just has variables. So instead of taking off 2y, what would we do instead to get all the y's to one side? We'll take off 10y. This ligament is correct that y does in fact equal 5. Yeah. Good questions so far. Well, let me find it all right. I'll like this one. We'll go. Again, our goal is to solve for n. And before we can start the solving part, we have to simplify. So it goes back to what we were talking about in Unit 1. So treat this as two separate problems. Do the left side simplify and simplify the right side. The left side is kind of routine. What are we going to do on the left? Distribute. But I don't see anything to distribute. Rep, it's a negative 1. So therefore the left side becomes what, Miss Brick? What does the left side become when you distribute it?
Negative 8n plus 2.
You are correct, ma'am. Left side's done. How do we work on the right side? Green, what do you think? I like it. What are you going to get?
10 and 3 in.
Not quite 3 in.
3 in.
You got it. Miss, how is the right side done? What do we have to do? That's all right. Correct. 3 and 10 are our like terms, so we're just going to put them together. And again, notice I didn't move anything side to side here, so that's why I'm not doing the opposite of 10 or the opposite of 3. 3 and 10 are on the same side, put them together. Okay? Anybody know what we formally call that in math? What? Yeah, we combine the like terms. Alright, so we did all that work just to get us to the point that we can now start to think about solving it. Okay? Variables and constants are on both sides, so now you want to remove the side that's least. Kyle, which side has less ends? Left or right?
Right?
Correct. So how am I going to remove the ends from the right side? Chance?
You need to add 30
Very good.
each side.
Mr. Kopus, where do we go from here?
Subtract 2.
Correct. Almost done. Let me bring it over here so it gets out of that desktop trial space. Ms. Evans, what are we going to do from here?
Gonna divide by 22.
Correct. Anybody got an answer for us? What? Not 2.
0.11.
No. No.
0.5
Gross.
equals 1/2.
1/2.
Okay.
Remember, you're dividing by 22, not by 11. So the top number is less than the bottom. It's a fraction. Watch your directions on MathXL because they will say, write the answer as an integer or as a simplified fraction. They will not let you put in 0.5. Okay? Almost there. Not done yet.
We have 1 or 2.
Just one today.
I gave up this one.
Okay. Sometimes we get some special equations. Like this one. Ashcraft, how are we going to simplify that left side? What do we get?
-12. Plus 1.
Is that it?
N.
Okay. Walker, what's up next?
The other side.
And we get?
10, 20 in, minus 60.
Rome. Russo, notice anything? Notice anything about our problem so far? Behringer?
One side is like subtracting, the other side is adding.
Agreed. What about the ends, guys? Yeah, notice the ends have the same, we have the same amount of ends on both sides. So if we go remove them, we can take them off of either side, doesn't matter. Look what's going to happen. Yeah, someone already said it. We're not going to have any more ends. It's no longer an open sentence. It's now a statement. Does negative 12 equal negative 60? Who said yes?
Wait.
No solution.
This equation has no solution. Because remember, when we go back here to example 1, if we put 2 in for x, we get the same number on both sides. Example 2, if we let 5 equal y, we get the same value on both sides. Same thing in example 3. If n is 1/2, we get the same thing on both sides. In example 4, there is no number we can put in for n to get the same number on both sides. It has no solution. That's one of your two types of special equations. If the variables disappear, and it's false. Negative 12 does not equal negative 60. This equation has no solutions. Your other special Phelps, what are we going to do?
Multiply 3 times 4, 3 times 4x.
What do we get?
12 plus 12x.
I already heard someone say something. What do you guys notice happened to our equations?
That's the same.
It's the same. Notice if I go ahead and take away the 12x from both sides, now you get a true statement. 12 is 12. This is what's known as an identity. And the solution are all real numbers. Just like in no solution, the variables go away because you get the same coefficients. But in this case, you get a true statement. 12 does in fact equal 12. And in no solution, you get a false statement. You get two different numbers. Okay? So if this occurs, you have an identity, and it's no real solution, all real numbers. That is today's lesson. Are there any questions?